When we spend so much time coordinating in BIM, we're figuring out the theoretical location to build all of the things, but inevitably the real world is never quite like the pixels. And that presents itself in so many different ways that can cause so many different problems on site. We have these pixel perfect models. People will spend, in cases, years working on these BIM models to make sure that every interaction is accounted for, every duct pass through, every hanger is all modeled. But when the core is 2 inches out, the pixels don't matter. You still have to account for that core. On top of that, it's human beings doing this work. It's a guy with a tape measure trying to add up 4 dimensions in the PDF that he's looking through to try and mark the ground with where this is supposed to go. And I don't know about you, but 15, 7 and 5/8 plus 14, 3 and 3/4 is really difficult to do in my head. These guys are really good at it, but the opportunity for error in the real world is just so high, even if all the pixels are in the right spot. And BIM being fully coordinated doesn't mean that everybody has the same design files, the same model revisions, the same information that they're actually using there on the job site. So even with a perfectly organized model and a perfect core, you may have somebody on Rev A and somebody on Rev C, and that alone, that'll cause a problem by itself. Where do I most often see things break down from moving from the digital to the real? The first is the physical building. When you're building a building with concrete or steel, those columns, those cores are never exactly where you think they're going to be. So even if the pixels are perfect, you're still going to have a core that's an inch out that you need that wall to line up with. And that's something that you have to deal with in the real world all the time. And that concrete expands and contracts. You have to account for the physical changes in the world. So where do you most often see things break down from digital to real? It's the people. People are using 80-page PDFs looking through and trying to do math in their heads of 17.5 and 3/8 plus 3/8 plus 14 4 1/4, and then measuring it with a tape measure off of a control point. That is a really difficult thing to do, especially given the heat or the cold and the pressure of the schedule and trying to coordinate with the rest of the guys on site. It's just a very error-prone process, and it's very hard to do even by the best guys. And that, you get this breakdown between translating those perfect pixels into a real building. Yeah, great example of where something was coordinated perfectly but failed during installation came from a project I was on where control was out by almost an inch and a half. And anybody measuring off of that would have put everything at least an inch and a half out, if not more in some cases, where Rugged, we went out, we have the robot. The first thing the robot does is check to make sure control is good. And the first thing it did was told us control is not good. And we were able to work with the customer, figure out the issue, get control reset for that job site, and then we're able to lay everything out. We probably saved hundreds of thousands of dollars of rework had they tried to build off of that original control set. We see a lot of assumptions from the VDC team, good or bad, that aren't necessarily true on site. One is that everybody's using the same revision. I've seen several people using several different revisions all to do their layout, and that just doesn't work out. Some people are using Rev B because they prefab using Rev B, even though we're on Rev D, and that causes these miscommunications in the field. Teams in the office often assume that everybody is measuring the same way on site, and that's just not true. You may have the MEP trade who's done a lot of prefab using a total station to stake out points for their hangers because they've already have all the sheet metal or the pipes all made. Whereas the drywaller, they might be measuring off the face of the column because they need to make that wall flush with the column. And at the end of the day, now you have a pipe that's supposed to go right up through the wall that's now a ½ inch out. It's very common. Every job site, you see some pipe not in some wall, and it's often because people are measuring differently off of the same data. Yeah, these gaps in communication scale with size. If we're talking a 50,000 square foot floor, you're going to have a certain amount of issues of people measuring off the wrong thing or miscommunications or mismeasurements or trying to deal with the real world. And as you scale up, those scale at best linearly, probably exponentially, where the bigger the facility is, the more opportunities there are for mistakes. And the more opportunities there are for mistakes, the more rework that needs done, the more the schedule lengthens, and the more problems you're going to run into at your final delivery. If I could fix one thing about how the industry handles the BIM-to-field handoff, it'd be coordinated layout. Let's do layout for everybody all at the same time. We're using the same control. The robot checks the control to make sure that the control is good. We're using the same drawing revision. We're using all the same information. And we can save 90% of the errors made in this part of the process by just using the robot. There's still pieces of the real world that you'll have to account for, like the core being out, but we can solve the bulk of all of the issues and get people building faster and delivering projects faster.